In Lesson 1, you learned that values describing a population are known as population parameters, and values describing a sample are known as sample statistics. Sample statistics are random variables because they vary from sample to sample. This means that if you have a population and you take one random sample and then a second random sample, those two samples would have different statistics. For example, if it were a categorical variable, the sample proportions would likely be different. Or, if it were a quantitative variable, the sample means, medians, standard deviations, and so on would likely be different. In this video, I'm going to use StatKey to demonstrate how we can construct a sampling distribution when the population values are all known. StatKey is an open access application. This means that it is free and available for anyone to use. StatKey offers two sampling distribution simulations. For a quantitative variable, we would construct a sampling distribution for a mean. For a categorical variable, we would construct a sampling distribution for a proportion. Let's look at an example of constructing a sampling distribution for a proportion. The default dataset in StatKey is the college graduates dataset. Let's start by working with this dataset. There is more information about this data in example 3.1 in your textbook. Essentially, U.S. Census data found that 27.5% of American adults have a bachelor's degree or higher. On the right here, we can see that the original population proportion is set to 0.275. This means that when we draw our simple random samples, they are being drawn from a population with a proportion of 0.275. When constructing a sampling distribution in StatKey from a known population, we can change the sample size. The default here is n equals 200. For this example, I will change this to n equals 100. If we were constructing a sampling distribution to construct a confidence interval or to conduct a hypothesis test, which you'll see next week, the sample size here would be set to the observed sample size in our research study. So we have a population proportion of 0.275 and a sample size of 100. These are the two things that we need to set in StatKey before constructing a sampling distribution for a proportion. Let's start by generating one sample. On the right, we can see that in our sample of 100, there were 35 individuals with a bachelor's degree or higher. This gives us a sample proportion of 0.350. This sample proportion is plotted on our sampling distribution dot plot. Let's generate another sample. In this second sample, there were 31 individuals with a bachelor's degree or higher out of 100. This gives us a sample proportion of 0.310. This second sample proportion is also plotted on our sampling distribution dot plot. The triangle and the number below are pointing to the mean of this sampling distribution dot plot. We could keep generating one sample at a time and plotting the sample proportions one by one, but StatKey has the option of generating 10, 100, or 1,000 samples at a time. I typically like to generate at least 5,000 samples to get a good picture of the sampling distribution. In addition to being able to see a visual representation of the sampling distribution in this dot plot, which we can see in this case is approximately normally distributed, in the upper right-hand corner of the plot, we are given the mean of the sampling distribution and the standard error. The standard error is the standard deviation of this sampling distribution. Note that this method of constructing a sampling distribution requires that we have all of the population values. or in this case, the population proportion value. In most cases, we don't know all of the population values. If we did, then we wouldn't need inferential statistics. In those cases, we can use bootstrapping methods, which you'll see in a later section. Bootstrapping methods use a known sample to construct a bootstrap sampling distribution, which will look very similar to this one. And those sampling distributions can be used to construct bootstrap confidence intervals.